this is the first year we are doing these trials. We don't have a yield data at this point, right? So we have some initial results that we'll talk about, but again, by next year we'll have some solid yield numbers to talk about if we are going to see a yield benefit enough to be using the technology that we are arguing for. Okay, so the basic idea we are choosing here is uniform seed placement, right? In terms of basically better singulation, you need to stay away from that. So in terms of a better seed to seed spacing, and then a more uniform seeding depth, just like what we do with corn and soybean planting, right? Right now, with using a seed drill, it's essentially a conventional spill, right? Where a metering system is basically based on your calibration. It's dropping a specific amount of seed. So you might not be getting an ideal seed spacing as well as seeding depth with that, right? You might be getting clumps of seeds. So that might cause poor germination and emergence, as well as poor crown root initiation. That can lead into poor tiller development, more variability within the canopy, right? It will minimize your resource use efficiency in terms of light interception or even nutrient or water use. So if we can do a better job with those uniform seed placement using a precision planter like the one sitting right here that we used, and Dennis will talk more about that. The hope is to get more uniform seed spacing, better singulation essentially, as well as seeding depth, and hopefully that will help with more uniform canopy, and collaborating that with your ideal row spacings as well as your seed to seed or within row spacing, and combine that with your even varieties, different architectures. You might have varieties with more upright or more prostate canopy, right? So combining all those factors, the goal is to design a canopy that can help us maximize resource use efficiency, will improve the yield potential while basically maintaining our input cost lower, as well as maybe giving a better management practice idea in terms of plants being at a more uniform growth stage. That will help with the management practice such as a fungicide application for head scab control, right? If your plants are at a uniform growth stage. So that's sort of our goal. So what we are doing to achieve that is we have some seed drill plots over here. So those are right here actually this is 7.5. So those plots are right here basically by that bucket. Those are planted with the seed drill at 4 different populations as you go down the block. So once we walk those plots, you can see as you move along, you will see the seeding rates change from a minimum of 750,000 plants up to 2.4 million seeds per acre. And then for the precision planter, we have 4 different row spacings that we are targeting, starting from 5 inches going up to 7.5, then 10 inches, and then all the way up to 15 inches. The reason we are including 15 is because we can currently do that using our corn and soybean planters, right? So we are evaluating again those multiple seeding rates within that row spacing as well, to see if we can come up with a better recommendation for a seeding rate in that kind of a row spacing. So again, going back to the basic concept, the idea is how we can do a better job with the seed to seed spacing as well as seeding depth. And if we are planting at a high seeding rate, such as 1.5 million, we are not getting too much space between the seeds anyways, right? So you might ask, why do that? So that's why we are maybe focusing more on the narrow rows and a lower seeding rate, so to speak. So we can give more seed to seed spacing. About 1 inch to 1.25 inches is what we are targeting. That can lead into up to 4 to 5 tillers per plant, right? So that way you might be getting enough number of heads per unit area. That's your first yield component, right? And then the second yield component being your number of seeds per head, and then that individual seed weight. So we're targeting a better seed to seed spacing that might give us just enough number of tillers. You don't want to be too low. Right now, with the seed drill, we might be getting up to only about half an inch or so seed to seed spacing, right? And that might only give us maybe higher tillers up front, but only 1 to 3 might go to the yield, right? So we are losing some yield potential because of that. You can even look at some of these plants here. These are from your seed drill pass, and you can see basically there are pretty decent number of tillers, heads at the top, but you can see a lot of these smaller tillers in the lower in the canopy, right? That might not be yielding as much as you want them to, because the seed to seed spacing wasn't ideal, right? If you compare that to some of these plants here using this planter, you can see we still have some of these smaller heads here, but overall they are more uniform at the top, right? And even if you will, once you are walking the plots, you can see I'm getting up to 3 to 4 tillers in some of these plants that are planted using a precision planter compared to 1 to 2 tillers over there. All right, any questions before we walk into the plots? So again, this is a concept we have, and then Dennis will talk here in a couple of minutes about the technology. Yes, sir.
Why have our machinery manufacturers not been able to do something with this spacing and drill it the same thing since the day it was built?
That's a good question. And Dennis, you wanna handle that? Being on the equipment side of things, right? But yeah, the goal, I mean, again, as a researcher, my goal is how to improve our singulations, right? And Dennis is working with Hosh to get a seed drill / planter over here that does a better job with singulation. So we might have our hands on that technology come next year. So we are hoping to get that by July, right? So I'll Dennis talk a little bit more about that.
All right. So are there any equipment manufacturers here? So the question was about, we've used the same drill on the 7-inch or 7.5-inch row spacing for 30 years or 40 years or maybe longer. Why haven't we improved the technology? I don't have a good answer to that, other than it's got to be return on investment for the companies that make the equipment. And it makes sense to me. If you're running a company that's in the business of selling equipment, if you can't produce enough volume and whatnot to make it pay to do it, why are you going to invest a lot of money into research and development? So that's one of the things that I think that why we're doing some of this stuff is we've talked quite a bit about since the wheat checkoff started about high management of wheat, and the high management of wheat that we've always talked about starts in the spring. Well, we start planting wheat in the fall. And so we need to be looking at, if we're going to talk about high yields and high potential, we need to be thinking about how we're getting the seed put in the ground. And that goes back to the planter and the equipment that we're using to do it. So if you look at the technology that's on corn planters and soybean planters, it has we've steadily been putting more and more things on there. You can tell your percent singulation, you can tell downforce, you can tell a whole lot of things. They got sensors on the Keaton seed firmer now that'll tell you your percent organic matter on every second as it plants on every row unit. The amount of data and information that you can get from these planters nowadays is amazing. But we're not quite there on wheat yet. So we're hoping to try to figure out something that is economically feasible for farmers to do. Yeah, and so the horse drill. Let me talk to you about the horse drill after we go up and look at the planter up there.
The plots that you saw out there were planted with this planter right here. This is just a standard monosome row unit planter. Nothing particular about it. We made a few modifications to do what we wanted to do with it. You'll notice the narrowest we can set this. I had a question about this out there. Is 10 inches. So how do we get the 5-inch row spacing? Well, we use auto steer and RTK to plant half the population one way, offset 5 inches, use auto steer and RTK to plant the second half of the population coming back. And you'll see there's places where it looks a little more like twin rows than it does like an actual spacing. That's the reason why. It's because that's as accurate as we can get with the RTK system. When you're trying to plant exactly 5 inches apart, you get just an inch sway either way, and that's how you get that kind of wobble and what it looks like out there. So we're doing the same thing to get the 7.5-inch spacing. We widen this out to 15s. We plant our 15-inch row spacing, and then we do, if it's a 7.5, we'll plant half of it going up, offset 7.5, come back and do the second half of our population. That was the way to make this the cheapest piece of equipment for us to buy. So the way this planter works is it uses just a standard seed disc system with vacuum on the back side. So the idea is it holds the seed, the vacuum on the back holds the seed to each hole. This has 2 rows of holes, which is not typical. Most corn and soybean planters would have 1 row of holes, and the holes are going to be quite a bit bigger. These are 1.5 millimeter holes, and there are 120 holes on each row of holes. So when this thing makes one complete revolution, it's going to drop 240 seeds if you got 100% singulation. Now, we did some testing. When this thing spins at about 25 RPMs, we can get 100% singulation. Okay? When you try to spin this thing faster than 25 RPMs, your singulation percent decreases. So at 1.6 million seeds per acre, at 2 miles per hour, that is the sweet spot for this. We can get 100% singulation. Or there's a calibration function on this where it spins the disc 5 times. If it has 240 seeds on it, 240 times 5 is 1200. We were getting 1198, 1203. We were right on the money. But so when let's say we keep 1.6 population, let's say we want to go another mile an hour faster. So instead of 2 mile an hour, we're going 3.5. This has to spin faster, doesn't it? Okay. We took it all the way up to 6 mile an hour, and when we got to 6 mile an hour, basically our percent singulation continued to decrease, and once we got up to 6 mile an hour, we were only getting about 82% singulation. How many of you would be happy with 82% singulation? What are you getting with corn and beans? 98, 99, yeah. So you're getting very good singulation on those things, but you're planting those at a much lower population than what we're trying to make this thing do. Okay? We are stretching the limits of what this technology can do.